Hi, it's Kevin, and today we'll talk about helpful drive-based examples. The first robot that teams built is known as a clawbot. This robot is a very easy build, with Vex even providing instructions on their website. The drive base on this robot is a 2-motor drive base with 4 200mm tire wheels. This drive base works fairly well at first, but in comparison to the competition, it's rather slow and clunky. Out of the many possible base configurations, how do you pick one which suits your team? The question to ask is how much mobility a robot needs. Remember that more mobility is not necessarily good because it is exponentially more difficult to build a complex drive base, and you may not have enough time to practice with it. A lot of teams create their own drive bases with different mechanisms, so let's take a look at what they do. The first type of movement we'll talk about is basic movement. This type of movement includes forwards, backwards, and spinning in place. It is the most basic configurations with 4 wheels that can traverse the entire field. Some robots with 2 wheels cannot spin in place, but they're very rare. The problem with this drive base is that it becomes harder to turn the larger you scale up the robot because the wheels are farther apart. Notice that this drive base can be improved by adding omni wheels.
The next type of movement you guys should consider is sideways movement. Sideways movement is very helpful in situations where you might not have enough room to turn. The simplest way to implement sideways movement is with an extra motor driving a wheel perpendicular to the robot. The drive base you may use is called an H-drive. It has 3 motors and 5 omnidirectional wheels. Managing the controls of an H-drive requires basic programming skills, and they have very good functionality for only 3 motors. However, if the robot gets too heavy, the sideways motor might cause balancing issues, making the robot topple. A solution could be to go to 6 omnidirectional wheels or build a holonomic drive base. Here to Kevin to talk about non-cardinal movement.
The third type of movement we'll talk about is non-cardinal movement. Non-cardinal just means a robot can move in directions that are not forward, backwards, or sideways. For example, some robots can move diagonally or even at an angle of 30 or 60 degrees. Robots that can perform these movements are called holonomic drives. These drive bases are useful when the robot would otherwise need to turn many times, therefore saving time. However, such robots are rare because they are more complex and require more motors. They also require a more complex programming code for their motion than the standard drive, since you need to find ways to translate movements of motors into something you can actually control. There are 2 types of holonomic drives we'll talk about, one with 3 wheels and one with 4. A holonomic drive with 3 wheels is called a Kiwi drive. This drive base has the most functions out of any practical Vex IQ drive base. It can travel in any direction of a regular 12-hour clock. This increased movement is not actually the main perk of this drive base. Instead, it is the fact that it only uses 3 motors, while still being holonomic. However, the Kiwi drive is less stable and has less force than many other drive bases and may get stuck or broken in messy fields. Second, a holonomic drive with 4 wheels is called an X-drive. This drive base can drive diagonally along with the regular functions of a drive base. This drive base is very robust and powerful. However, it uses 4 motors, leaving less for the specialized functions of the robot.
Alright, next up we need to figure out if these drive bases are useful or not. These drive bases are incredible but provide extremely unique functions. The only problem with these drive bases is whether they are useful or not, or necessary actually. So let's rewind to 2019. In this video you can see this game was centered around bringing these hubs across the field, and you're going to see in this clip that the robot does not require any of the special bases. The robots here were considered metabots. And these robots were called that as they were the robots everyone built, the meta. You would see hundreds of teams build the exact same thing, with the build quality being the single difference. While these robots were the most popular, a team actually used an X drive base, which got them a very high score. The robot was a robot nobody else had thought, and it granted them excellent results as they took a chance with this robot. While deciding on a drive base, do not let the Meta robot discourage any ideas you might have for your holonomic or H drive base. So now let's talk about Teleop Programming. Coding in Vex IQ is fairly simple. We will go through a very basic tutorial on how to program. There are two types of programs, in Teleop and Autonomous. Today we will be talking about the Teleop program, which is meant to help you maneuver and control your robot and configure the controls of your Vex controller. The simplest way of Teleop is just configuring the controls using the device management. To do this, you must click Open Examples, click Clawbot with Drivetrain, and click on this little button here called Devices and start configuring your robot. If you're wondering what this page is, it's codeiq.vex.com, or you can download the application on any of your devices. You can add motors, delete motors, or reconfigure the motors in any method you would like. To change the schematic of your controller, add a controller and click on the controller to change the controls from there. From there, you can make any configuration of your drivetrain. This is especially useful for drivetrains, which can go multiple directions. The second level of Teleop programming is to add special functions to your controller. For example, it is possible to link a button on your controller to a difficult maneuver if it might be difficult to pull off multiple times in a row. You can also set software limits on how much a motor can rotate so you don't accidentally break your robot. Finally, you can add sensors to your robot, which can help you align yourself with some field element. This isn't an upper bound to do what you can program your controller to do, but remember that a program cannot adapt, and sometimes it is better for a human to be doing it. In the end, it is super simple to get down a Teleop program, and it can be a great quality of life improvement. Alright, that's it for today's video. I really hope you guys enjoyed. If you have any questions, feel free to leave a comment down below. Check out the links in the description if you need any help with anything. They'll be very useful, and they'll provide a lot of information. I'll catch you guys in the next one. Have a great day.